this video, I'm gonna go over uh, some type of overview of data visualization and briefly about data quality and the differences between data analytics and visual analytics, and then some case studies. So, when we talk in general about visualization and its importance, we mention in details how the impact of summarizing data in a visual representation can help telling a story about our data. So we're gonna go a little bit about the history of the data visualization and from where it started, and then we're gonna do some type of comparison between the data visualization and data storytelling when you are presenting a story about what you found in your data, what kind of patterns you found in your data. So let us start with some groundwork about the definitions and the purposes of data visualization. So as a definition, data visualization is the practice of representing data visually. Okay. And technically, we can divide that into four type of cases for using data visualization. So what you do, usually you record something or you have some type of a graphic record of something historically, let's put it in this way. Or maybe you are analyzing data to try to reveal some type of trends and patterns that support some reasoning about what you found in your data. And also maybe to confirm some type of hypothesis about your data through data discovery and exploration. And finally, it's a way to communicate insights or findings about your data. So to transform information with the influence of purposeful design and analytics with the intent of encoding and conveying information otherwise difficult to understand in a meaningful way. And I would say typically is what you are trying to do, you're trying to transform information with the influence of purposeful design and analytics, and in a way you're trying to encode this information. And yes, because it's very difficult to represent a meaningful story from that data, especially when you have millions of records and millions of attributes. So it's really good. Visualization can help you convey quickly and easily and more understandably information from these big, huge data. What kind of categories of data visualization? You might find both explanatory and exploratory, and then you might find a mix between those and what we call them the hybrid. So the exploratory, the intent of the exploratory data visualization is where imagine the following: as an analyst, you are trying to explore data and find something to tell. Curiosity driven, maybe a lot of messiness in the data and you want to prove a point. Using interactive visualization dashboard, maybe to pose some new questions from the data that you have. And in general, you are trying to discover some type of iterative information or pattern in your data. Where the explanatory type, it's more you're trying to explain. Let's put it in this way. You are trying to do some type of data story. You are trying, so the goal here will be telling a story or communicating what you found in your data, or some answers to some hypothetical questions you put, or you are trying to prove a point or a way to support a decision, so it can be taken and considered, to communicate information, and to increase the efficiency of production line or your business. The hybrid, and here where you see that visualization, often what we are seeing actually, it's a mix between those two domains, and that could include things like the infographic, which is really popular in those days. Especially you see them on TV advertisement, you see them in magazines, in newspaper. A very quick comparison or quick way to show you information without representing a very difficult, heavy overload of numbers to your audience. And you might be surprised to find out that these graphics were actually made with Tableau, the ones you see here. And to learn how you can do those, we're not going to cover all the topics in Tableau, so I'm adding some type of visualization galleries available for you in Tableau with complete cases, so you can examine after finishing the course. But yes, you can do these things with Tableau. Okay, interactive way, and we've seen some type of interactive dashboards in some cases so far, but also you can be more innovative and incorporate pictures as well with your visualization analytical view of your data. Okay, so sometimes data visualization is the only way to see and understand data, and especially when you have big data. So if you have, as I said, millions or maybe billions of rows of data or records of data, and you have 10,000 or 100,000 of variables or attributes, or you call it independent variables, it's very difficult to get the message across to summarize the data. So here where visualization would be an easy way for you to explain it. Not only that, sometimes it's really difficult just looking at the numbers to see the patterns in your data. And one of the really basic example that mentioned almost in every visualization book is what is called the Anscombe's Quartet, and we're going to look at this. So what was found in this data, so as you can see, we have here about 4 different data sets. Set A with 2 variables x and y. So look at them, like each column in this data represent one data set with 2 variables, x variable and the y variable. And what else? We have 2 items in each of those data sets. And when you look at the values of x and y in those data sets, you see they are vary completely. And you will never guess that there is some type of commonality or differences between this data until you do the math. So if you try to sum up all the value of x and divide them by the number of values by 10, you get the mean, and you notice that the mean of x for the data set A is exactly the same, number 9 here, exactly the same for the set B, exactly the same for set C, and exactly the same for set D. Also, if you do the mean for y for the set A, you will find it's exactly the same for each one of those. Then if you do the standard deviation, and you'll find exactly those values are the same. Look at the x's in each of those data sets and the y's in those data sets. Okay, then if you look at the correlation, also you get the same results. Correlation of all those data sets between x and y is identical. Now let's step even further. Let's create a linear regression. And as you can see here, the linear regression has exactly the same formula for y with regard to x in all of them. So here you might say those data sets are identical. Those 4 data sets are really identical. And that's phenomena that started a long time ago that helped the visualization domain to grow, because without looking and visually plotting this data, you will not uh, figure out that those are not similar data sets at all. So if you try to plot the x and y of each of those data sets, you will come up with following. So the data set 1, you get this type of linear regression. As you can see, really the data distributed around your linear regression or the trend line. Whereas if you look at the second data set, you can see some type of polynomial relationship in the data. And the third data set, you will see it is almost a line relationship and you have one outlier. Whereas the last one, we have really one outlier here. That's one that caused that you have this line. Linear regression looks like this. So if you delete that outlier, then your linear model is going to be a parallel line to your y's. That's the line that's going to fit your data. So as you can see, each one of these data sets, the relationship between x and y, linear regression model, the blue lines in each one of those, yes, they are exactly the same, but we have a totally different type of data. Correlation is the same, but they are not identical. So only visually we were able to find this strange differences in this data. So this is the point where people started to understand that visualization is really important to better understand the data. And more recent examples, so again, the purpose of visualization is to reveal intuitive insights at a glance. That's the whole idea. So we should be able to see insights immediately in your data. So we can do that here when I have a data like this, which is a mix between numbers and also text and also timeline, like years of. So this is the type of show names with the time period, the name characters, and the show creators, etc. So really, when you have data like this, you cannot summarize it, no matter how color coding you did in your Excel file. It's very difficult to represent it. However, if you put it visually in Tableau, as you can see here, you can immediately tell a story about this data. Okay, so the average rating, maybe if we took by user rating in your x-axis, and in your y-axis, I put the my rating. And now you can see that you can really come up with a story. So as you see here, the Sherlock Holmes shows was rated almost, in my rating, was almost higher than the half, the 50%. So my rating was almost, so if you look at it here, almost 9 out of 10, and also was considered as the average user rating in total. So we agreed on that. Okay, where in my rating, the project runway, I give it 8.2. However, the average rating of all the people watched that show was lower even than 7.4. So it wasn't close to me. So that's a very good story to talk about when you look at it in this way, whereas it was really difficult when you look at it in Excel file, no matter how much time you spend in color coding. So when big data meets visualization, we can say that we are creating some type of evolution of business informatics, or what you called it, the BI, business intelligence as well is considered. So you can see that the evolution of business intelligence started from long time ago, in between 80s and 90s, when we started to build data warehousing. Then we started to talk about business intelligence between 2000 and 2005, and then we moved into analytics and business analytics after 2010. So it wasn't a long time ago, one decade, when this evolution of analytics started to evolve. Even the naming as a major analytics didn't exist until the last 5 years. So, and it just was brought from the data mining field into the business domain, because they discovered that they can take advantage of data mining to make more profit. I'm talking about businesses and industry. So it helped this domain to evolve quicker. So the big era of big data, and we talk a lot about big data, and a lot of people talk about the 3 V's of the big data. So what are those? I assume you are familiar with those, or heard about them, or read about them already in our book. So those are, and actually they are extended. The last couple of years, you can see people mentioning the 4 V's of big data, and 5 V's and 6 V's. Google it a little bit and you see what I mean about that. So this is the more standard one. You talk about the 3 V's, so that's why I mentioned only those. The volume, so the first V refer to the volume, so how much data you have. 40 billion user photos on Facebook stored. Okay. Variety, so you have different type of information, especially over the web. It used to be hyperlink in the past. We used to have only links from one page to another page. You click the link, hyperlink, and to go to another page. Then we started to incorporate pictures. So now we have hyperlinks that take us to pictures, and then we started to put audio, the concept of the podcasting, where you have the syndication RSS feed on websites, if you remember those. So that's another type variety of information. After that, we started to see videos. YouTube emerged by those 3 kids who needed to watch videos and during their prom party, and one of them said, yeah, I have that video, but it's in the dorm. So they come up with ideas that they can stream video without needing to bring those videos, and YouTube was created, and it was bought back from them by Google, and now we have YouTube that all of us are using. So this is another type of variety different of information. So you have audio, video, and you have text, you have a PDF file you can link to, HTML, you have PHP code, you have GSP, JavaScript pages, Python now, scripting appears, and you have many different variety of information presented in different ways. Then the 3 V is the velocity, how fast. That's really important because you need information super fast. You want to be able to handle it and stream it, and to be able to give it quickly, not only over the web. We're talking about maybe using Amazon Web Services, using Google services, or also the third competitor, which is still behind, Microsoft, so Azure services. This is where we're talking about velocity, moving to the cloud, having big data repositories, and you are able to interact with this data. One example is decoding the human genome, that it was really difficult to accomplish until we reached the the area of big data, where we were able to store huge amount of data and look at the pattern amongst them and decode the DNA of human. So it really helped. So all this invention helped us to even in science to accomplish things we couldn't do that in the past. Okay, so more data now than ever, of course. So if just a small comparison over here, we used to talk about the gigabytes in the past. So if you go even further back, so we used to talk about imagine the following. If you write one word, your name, and your name, let's say, consists of 8 characters, and let's imagine that, which what really is, each one character represented by 1 byte, which is 8 bits. So imagine that. So one character of your name is 1 byte. So let's say your name maximum, let's say you have 10 character, so you have 10 bytes to represent your name. And then let's move further. If you are having you're writing in Word document, and your Word document is amount of 1 kilobyte, which means 1000 bytes. Okay, so the kilo is 1000, so you have 1000 bytes. And then if you have a document that of the size of millions of bytes, so we're talking about moving from megabytes to thousand of megabytes. So we're talking here about gigabytes, so we are now in this area. So millions of bytes, it's equivalent to a gigabyte. Okay, and then if you go even further, you are seeing a more evolving values of the data, and you're hearing more terminologies, and also mentioned in your book, the terabyte and more. So this is how you count and how the numbers are exceeding. So in the past, we didn't, we were not able to exceed the numbers of size, because computers are not capable of handling big sizes. But now you can purchase a laptop, like a Mac laptop I'm using now, Mac Pro, that has 4 terabyte solid drive. Amazing. Even I cannot imagine I have that. So 4 terabyte of solid hard disk with 32 gigabyte of RAM. Okay, and then we're talking about the processor, the Intel processor, which is the generation 10 of Intel. So I can do on this laptop what I used to do on on workstation, even on mainframe computer, I would say 5-10 years ago, and I can do it on my laptop anywhere and even faster. So technology changed, everything changed, and the storage became bigger and more easier to be stored, and quicker to be handled. And the internet also, the speed of the internet helps us with fiber optics to achieve all those. Okay, so big data is fast. So the internet now is, we are talking about real time, you are streaming, and you can see all the social media that pop up, and a lot of apps have started to generate a lot of data. So we are in continuous what you name it, real time, instant way producing data. So wherever you go, if your cell phone is in your pocket, actually your geolocation is recorded. Whatever actions you are making, like you turn on your car, even with pushing your remote control, or even without pushing, just being close to your car, the data being collected from your car that you're close. So if all this is synced over the internet, all this information is turned into data and saved. You're running with your Apple Watch, everything is saved. So all this data is providing for us a huge amount of information that we can look at and find patterns, mine this data, look at meaningful information about it. And I decided at the end of this course to give you a complete YouTube that I teach data mining for the business data analytics program. So if you are interested in learning how to do the things you learn theoretically in this course from the textbook, there are plenty of cases there with data on YouTube channel, so you can download the data, watch the videos, and implement it. So I have like some of those case scenarios predicting if someone's gonna have second heart attack or not. And you can see how it's been done with video and data, and using an application called Rapid Miner. What else? Detecting what is the best sport for a high school kid before going to college, instead of playing different type of sports based on battery test, predicting which one is the best based on the data and historical data. What else? Predicting the inventory capacity in business, instead of running out of some stock and then losing the businesses in the area that you have your own business in, or not overstock your inventory and losing money because nobody's gonna buy that amount. So a lot of interesting cases. Hopefully you will use them over the summer and take advantage of that channel I created on YouTube. Okay, so as I said here, a lot of data generated by the applications through your mobile devices, computer devices, your car, your if you have a smart refrigerator, if you have a smart TV, everything has been turned into data and streamed and can be saved and discovered and mined, and what else, pattern can be found in this data. Okay, so what else? This is really a good way to summarize what's happening all over the world with regard of all these applications that we use on daily basis. How many over the internet usage by users to all those popular applications such as Amazon or Netflix, and LinkedIn, the Snapchat, and how the distribution of those applications over the time. So to me, as a surprising finding here in 2018, that every minute of the day you have users that shared about 2 million snaps on Snapchat. I know that application, I downloaded it on my phone, but I'm not a big fan of it. And I know the new generation loves it, and I know my kids love it. What else? The weather channel. Okay, that's good. We still have that app for forecasting is regularly used. So there are about, and when we're talking about every minute of the day, we have about 18 million requests for forecasting the weather from the weather channel. Amazon, how many packages has been shipped per minute of the day? About 1,111 packages, and I bet during this period of time, this number jumped 10 times, if it's not hundred of times, and etc. You can see how those applications are competing with each others, and how some of them almost gonna leave us and vanish, and how some others gonna stay and evolve and maybe turn to different type of user usage applications. Okay, the ability to take data, so based on the chief economist of Google, Hal Varians, what he said, the ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it, that is going to be the hugely important skill in the next decade, and decades even, plural. So because now we really do have essentially free and ubiquitous data, and that's true. In future, it will not be so cheap to have access to those data. We don't know what's going to happen, but that's a fact. Okay, so if you want to look at visual analytics and how it's going to grow, so let us look at it a little bit. So data visualization classes now taught at universities all over the world. And Tableau is one of the main applications that have been used. Specifically, the skills that is needed is to be able to visually talk about the data and explain it and tell a story about the data and communicate what you found, instead of just using your statistical skills or your data mining or computer science skills. That's not needed anymore. What is really needed is to be able to communicate and tell a story from the data. And here's some of the business analytics programs across the US and the growth of those over the last decade. And you can see that it started business analytics when we started at Western Kentucky University was a bachelor degree in 2014. We're the only university to provide undergraduate degree in business data analytics. Everyone jumped into the domain of business analytics by providing a master degree. So it was really a risky business for us to do that. Now we are opening next semester. You will see 2 degrees of master, and one in business data analytics, and will be online completely, and the second one will be for cybersecurity analytics, and those will be for managers and CEOs and who want to learn about those, but they don't want to be the one coding. We are not looking for someone who does the computer science anymore. We want to empower managers with the information on how to prevent hacking in your organization, to be knowledgeable about it, and also not only that, not only to prevent. Most of the time is the fact is he's gonna be hacked no matter what, and what the action you take or the advice you give to your director to do after the fact is more important even than preventing, because no matter how much you pay for the infrastructure and the firewall you create for your company, always the hacker is going to be going to hate you no matter what you do, no matter how much you spend. So the idea is, if something happened wrong, how you can act so quickly and know and have the skills to give your director the advice to do things and to hire maybe some third party to fix the problem so quickly and manage it. You're not the one gonna fix it. You're not the programmer and you're not the security expert. But if you know what you should do in those cases, that's more important, especially as a business uh, manager. Okay, so let's continue a little bit here. So working in data visualization in US, as you can see, it's all distributed in all over US. You see a lot of jobs started to appear in New York and in San Francisco. You see the highest with darker color, the highest demand over there. Okay. It's it's expanding more and more, and Tableau really is is taking a big jump into the market. And I'm not gonna name the company who bought Tableau by the end of 2019, because who knows when I post this video next semester who gonna buy them too. So just Google it and you'll find out. So yes, and they paid billions of dollars to buy Tableau. Okay, but still, Tableau provide educational entities for universities like you and me to learn and use and educate ourselves in it. So historically, from where the idea of visualization started, so going back to the drawing in the caves, so a long time ago, we're talking about before even BC area. So in France, 30,000 to 28,000 BCE, where um, Chauvet Cave, Ardèche in France, which is dated, as I said, in BC. It's one who was thought that to be the house of the oldest representation of art, and it has more than 1,000 painting of predators like the mammoths and the a lot of sophisticated painting that you can find over there. And I'll provide the link in the PowerPoint so you can really go further and watch those. And also, what should I say? A lot of information about this is provided in the Smithsonian magazine, as a gift for uh, people to get access to what that type of historical art is all about. So it thanks to them for allowing us to use those pictures, for example. Okay, beside that, if you're going to look at the timeline for notably moments in data visualization history, in 1956, so Descartes introduced the Cartesian coordination system, which is we are all familiar with. In 1821, the Playfairs, the cost suite, which is was introduced during the time line of the graph and bar and pie chart were in that area. So we're talking about between 1806 and 1831. Then it's really important to mention that in 1869, the Minard's iconic Napoleon's March, the flow map, which we're going to see in a couple of slides, which is published and followed by Hannibal. So if you remember Hannibal from Tunisia, he was one of the most known. Uh, is not a soldier. He's more was a he was able to defeat. He was the leader that defeated Rome and kicked them out of invading Tunisia and take over the land. If you watch Phantom of the Opera, the beginning of it talks about the story of Hannibal, and you can watch, you can Google a little bit Hannibal, not Hannibal the movie, the scary one, the one who eats meat. No, it's I'm talking about the actual Hannibal who was really compared to Alexander the Great with his mentality in fighting. So if you Google a little bit, he was one of the very known leader and you know captains. I don't know, call it. Marshal at that time who led his troops against Rome and kicked them out of Tunisia. After that, we look at John Tukey, and he is one of the most popular scientists, American, who introduced the concept of exploratory data analysis and inspiring the development of the software of statistical computing. And we rely a lot on his theory and concept, especially when you do surveys. So if that name, a little bit remind you when you do some type of rating surveys, you might remember his name. And after that, mentioning Edward Tufte, who published the visual display of quantitative information, one of the most famous authors in 1983, and a lot of books being written by him and introduced, and he's really one of the main players in the field of visualization, data visualization. Okay, so here's back in the century talking about the even in 1950s in Egypt how Claudius Poutlem was providing a thorough treatise on astronomy and solar and the moon, the lunar, and the planetary theory. Okay, and this is one of his publications on the right side. Okay, so we a copy of the Almagest from the 19th century in Greek. It was written in Greek. Okay, after that, I should mention, of course, Descartes, René Descartes, and in 17th century, he's the one, he represented the coordination So we owe him a lot for learning how to do a lot of our visualization, even at the beginning of learning the Euclidean distance and to do geometry and algebra and what is known the Cartesian coordination system. After that, I should mention William. So William Playfair, who was in early 19th century, the Scottish engineer and political economist. So he's the founder of a graphical method of statistics, the first time to show, and he also developed a new design to improve what was existed at that time, systematic visual representation of linear algorithmic. So William Playfair, he was born in 22 of September in 1759, and he died in February 11 of 1823. So he was an engineer, as I said, Scottish engineer, and he was really known for his influence on the graphical method. Okay, and one of the things that really always referenced him is, as you can see in the lower chart, is doing the time series analysis. So he was the one who introduced that. Also, the bar chart and pie chart in general. Okay. Beside that, this is one of his really famous charts, which is called the cost of wheat in 1821. Really a good representation views of graph. If you think about, we're talking about 1821, long time ago. Now, the one I mentioned also about Napoleon map of Napoleon of Russia campaign. So that's really famous, and it goes to the early 19th century, the one at the bottom, and it's really famous map because you think about in that time. We're talking about between 1780s and 1870s. It was one of the best statistical graph ever drawn, and a lot of the credit goes to Charles Minard for this, as a French civil engineer who was able to produce array of graphic, combined many data points into compelling visual story that you can see down, the trends over time. That's at the time to think of someone doing almost tableau in his head and with his hand. So almost he produced about 70 plus depictions, including thematical maps and graphic tablets with cross tables between that period of time. Okay, and this is what is called the cattle composition, the cattle consumption in 1859. Again, to look at it in this way and you think about someone doing this by hand, that's amazing. And this is the one I was talking about, just in a bigger scales. So it shows the flow map, and it consider Napoleon's march. So this represent what Napoleon did, and by as I said, Minard, and it shows the size of his army during the Russian campaign where he invaded Russia in 1812. So it starts from the left with the width of the ribbon, thickness that represent the number of his armies, and the thin when it goes out is as you're going in his conquer to in conquering Moscow. So as you can see, so the drop in the number of army until here in Moscow. So you can tell how many people he lost to Napoleon during this period of time. Um, what else he did with that? So it reflects actually about 400 plus thousand of soldier who dropped to 100,000, so almost one fourth of his the size of his army dropped during that war. And the turnaround that happened in winter and the retreat and return was only 10,000 men, if you recall that. So this is a retreat in the black, and going back was only 10,000 men. It's a very good representation. It shows the story, it shows the success, and also the story about human drama. Um, and nobody did this before, so it really was a very clever way, brilliant contribution to information graphic, for him, and that what really he earned the distinction of being called the Edward Tufte leading expert as authoring, way. Uh, so Edward Tufte, I mentioned before, Edward Tufte, who is leading expert. So he mentioned what Minard did with this visualization, and how he changed the way people look at data, and how to explain it. How to represent it visually using just the drawing and telling a story over time. Okay, and the recognition by Edward Tufte to Minard by saying that maybe he considered him that as the best statistical graphic ever drawn in the history of visualization. So he gave him a huge credit. Another visualization known by Minard is similar to that, the Hannibal War, as I mentioned before. Very similar representation. So Hannibal trip through Italy was very similar, but here we can see the axis on this chart, and the geographical representation. It's following the actual route that Hannibal took. Anyway, these examples, I would say, represent amazing stories with pure presentation pieces. So telling a story, I would say this also, using data visualization for analytics and for presentations or telling stories isn't always the same. So we have to distinguish some facts when we are talking about storytelling and about analytics, and what tools you're using and what kind of chart you should use based on the data you have. And I'm going to mention those in upcoming class or video. Okay, we cannot leave the data visualization history without mentioning Jacques Bartin, who was also a French recognized figure, who was a cartographer and theorist, and a lot of publications in graphics, goes and being acknowledged by him. And what he was recognized is how he looked at visualization and how human perception of visualization and what kind of rules you can follow when you are doing some visualization. So the more about the process of visualization in the brain of the human being. So it's really, his papers, the semiology, he authored a lot of maps and articles and papers, but that was the most distinguished one. uh, graphics known about. So, and it was between the period 1918 to 2010. Okay. And of course, we have to go to the statistician that was the breakthrough in moving the visualization into statistics with the American John Tuckey. So we have to move to that in the 20th century. So he's the one who come up with the idea of the box plot to do some type of exploratory data analysis in 1977. What else about him? He worked in Bell Labs, by the way, and he developed a lot of theory and wrote a lot of articles and books in relation to that. Um, he is the one who invented, as I said, the box plot, but also if you know the whisker plot, also you know he get the credit for those. Also, he wrote other type of plots such as the bag plot and violin plot. They didn't become very popular, but he's the one who was behind it. And actually, he was the first one who coined the term byte. You know, where we say um, so we were talking about if you write your name, let's say, consisted of 10 characters, and imagine each letter on your name will need a storage of 1 byte, which is 8 bits. So he didn't invent the byte, sorry, he invented the bit. So the 1 bit, 10 bit. Okay, so one bit. Okay. Uh, the binary coding, let's put it in this way, 0 1. So those are the type of visualization that is very famous about inventing. So the box plot, histograms, Pareto chart, and the scatter plots, those are the things that being introduced during the 20th century and became more popular during this time. Okay, again, a very famous statistician that I have been mentioning in a couple of previous slides, Edward Tufte. He is American statistician, professor emerite of political science and statistics and computer science at Yale University. He was born in 1942, and he's still writing and he's still producing work. He was credited as a pioneer in teaching the fundamental skills required for visual communication. This is where the break between computer science and political science. So you can see this intertwined field that you need to communicate information using data, but at the same time, you need to tell a story. So he was one of the earliest authors in the data visualization field. And of course, we should give credit when we talk of visualization. You have to remember some type of the most advanced development that we're using, the Mac computers, Apple. So I give the credit, of course. Those are the events that let us jump from using DOS, if you remember DOS. With Microsoft, we used to use only this black screen and the green code to do all our command line by keyboard. We didn't even have a mouse. So if you are or your parents told you stories about those, and then how Apple just come up with very nice user interface computer. The Xerox Palo Alto Research Center, Xerox Spark, if you remember that, using the interface, visual interface, and using the mouse. That's the invention by them. And of course, the Apple computer were introduced, the Macintosh. And we don't forget Steve Jobs, who made really a big influence in the area of visual computing. not only in Apple. Uh, you can give him huge credit for even moving the music industry with the concept of synchronization, uh, when he imagined that he can have a an iPod at that time to sing in music while he's running. So merging all this invention between visual interfaces, very good, computer, very detailed computers with high tech visualization, easy to use, and with the mobile moving, inventing iPhone was one of the breakthrough in the mobile devices that really led us to where we are today. I don't think any invention Apple did after he passed away. So whatever he did, they are capitalizing on it. That's it. Okay, so what else? We should talk about some type of the Coxcomb plot. You see that now famous in Tableau to look at those stuff. So in 1858, similar in the 21st century type of visualization, what they used to call it here a connected scatter plot. Very weird way of visualization, and actually it belonged to Katy Pick, who was popular science, telling a story about the employment and unemployment. So you start from there, and it is very didn't really succeed that much, but we see an enhancement version of this type of graph. What else? I should mention also this type of graphic using the visualization of icons and pictures within converting numbers by the size and the pictures. Also, Tableau can do stuff like this. Also, another way of representation, the percent of US population by age group. As you can see, this is what usually we call infographics. The left is the male, the female to the right, and this is data brought from the Pew Research Center. So if you Google, you can get a lot of data from that institute. Actually, I use a lot of data from them to do research. And for example, there was an analysis and surveys for all the Americans' opinion after Snowden, leaking the information. So the survey collected data about people opinions after that, and about Edward Snowden, and most of the people were more shocked about how their privacy was breached than claiming that the act he did was wrong or right. They were more concerned about their social media data, and a lot of people actually left Facebook based on that survey. It's a national survey. You can Google it and you can find the data from that. You have to subscribe with your email and to verify that this is you, and then request the data and they send it to you. It's really a recognizable institute to get data from. But again, you can visually do this, and you can see here some type of storytelling here, comparison between male and female. In a split of second you can get the input, okay, a story. And we can do this type of animation with Tableau. We're gonna see it in upcoming video. Okay, then to know if you want to do a comparison, we did this in Tableau previously, the old-fashioned way and the new way in Tableau. So this is the evolution of data visualization, how it used to be in the past and how now you're looking at data visualization, representation. What else? Very important to talk about the data quality when you are doing data visualization, because you have always to question. So very important, if the data is not good data. There is a concept from the board from the data mining, garbage in, garbage out. No matter what, I give you millions of records, and if those records of data are garbage, there's a lot of missing data, there's miscoded data. No matter how much you're gonna clean this data, if it's a huge percentage of it is bad, no matter how much you work on this data and you present it for me in a very good visualization, it's gonna be garbage because there is no story can tell from it if the data was not correctly collected and not well coded, and there is mistrust in that data. So always you have to question any data in future you see in your work. From where's this data? Give me the dictionary of the data to know how to deal with it. So those are the questions you have to consider when you are dealing with data. Questions, what else? So there was a press release, I believe, from 2011. So as you can see in the published date 2011. So this is after the financial crisis, which was driven primarily by a mortgage crisis. So the National Association of the Realtors, which is known by NAR, has some of best economists in the world consulting, studying, and publishing about the real estate market. Their numbers are published regularly, and market uses those numbers as a common guide of how things are in the housing market. But there is a major issue here. So in December 2011, they announced that they had found an error in their numbers. As it turns out, it was a major error. So from 2007, pre-recession, we could say, through the end of 2011, they were double counting sales of certain homes. So as result of that error, they had to revise all their sales numbers. And so not only this, they had to revise all the data. At the same time, what happened to their value asset and their sales values dropped completely down. So how did this happen? How did an organization with world-class talent make a mistake like this? So the data actually for the home sales in the collected repositories were in multiple listing services, what they call it MLS. So these MLS system across country gather and report the data for their area. The issue arises when homes are on the border of MLS. So there were homes entered into 2 or more MLS systems, so that when the house was reported as sold, it was reported by more than one MLS system, and this way it was doubly counted. So a big mistake. You can lose your credibility in a mistake like this. What else? There's always a challenge to have good quality data, and the cost of bad data exceeds 600 billion for US businesses annually. Nearly 50% say data quality is the greatest barrier to realizing value for business analytics. So poor data has been cited as the number one reason for project overruns. For a medium-sized Fortune 1000 companies, 10% increase in data usability would increase revenues by $2 billion. So really, data are really important to be clean, to be high quality. So you need always to find a way, especially using the exploratory data analysis to help you find insight into the data, and also can help you explore the quality and the veracity of the data. So that's something you should be aware of. So good data is clean, relevant, trusted, and can be leveraged. That's really important. Okay, so here is one of those type of problems you could see in data. So where do my highest value subscribers live? So as you can see, people maybe they source number one, they coded the state Ohio as Ohio. Source number two, they abbreviated to OH. Source number three, they just abbreviated to O. So when you have this data source, instead of finding the total number of information in one category, state of Ohio, you're going to find three different output from different type of data entry. This is the type of problems that you will face, you know, in reality, in real life. So that's where a lot of time you spend to clean your data and to find what is error. Sometimes copy and paste, that's really typical happening in data in Excel. So as you can see here, someone copied and paste and then look at the data here, shifted to the right. Those columns should be underneath this. This is really typical problem in Excel. And a lot of people spend time just fixing, and now look at this, someone fixed it, and what happened, shifted the cells left or right and really mixed data type that you will not be able to run anything on it. So that's the problem with data. Sometimes people delete data by mistakes, and even this is bigger problem, you cannot retrieve that data, you cannot fix anything if you don't have the data, someone deleted it. So creating good data set, which is really a technical challenge, and sometimes it's gonna you relying on the data warehousing or to the information technology center to give you data, to query the data for you, especially in big businesses. So you are not the one who is coding or running the SQL, but when you're gonna rely on someone give you this data, you have to question how the data been collected, from which data sources, not how, but from where, and asking the information being collected, the meaning of those data, what is called the data dictionary. So acquiring your data, usually what is called, you have a flat file, it's like you see in Excel sometimes, or this is a comma separate value, the file with extension .csv, that can open in any application in the world, including Excel. And any statistical platform, SAS, Stata, Jump, what else, RapidMiner, even data mining, I'm talking applications, SAS Enterprise Miners, SAS Enterprise Guide, SAS Engine, the standard or studio, all those can understand the flat file, the .csv. You might get some data from transactional system, operational data storage, and from data warehousing. And in Tableau, as we notice, I always give you a data that already made, but also I have to show you some tricks when you have data not really prepared well, how you have to convert it to be understood by Tableau. So I should give you a small summary in the next video. Okay. Analytical data modeling, so we saw that in Tableau when we talked about the dimensions and the measures. Okay, so you have to remember those two, the differentiation between those. So the dimensions, those are, if you think about it, it's like categorical data, name of cities, name of products, okay, so this is more categorical data. Whereas a measurement, those are those things that you can count, okay, and you can do mathematical operation on them. Analytical data model sample, you can see this type of sampling, especially if you are working in the data warehousing. Not gonna touch base on those, but if you are taking a SQL course, so it's good to remind you of that type of modeling. This, for example, is the star schema. So we're gonna simplify. How we're gonna simplify? So we're gonna have Excel data. It's preferable to have a data set flat looking and to be able to represent it in a way that Tableau can understand it. So if you look at this data, the question is which are dimensions and which are measures. So spend some time, maybe pause the video, answer that question. So we have the date, we have customers IDs, customer names. Okay, so this is each column represent a variable, order ID, category of what they purchased, the product ID, the brand, the product name, the agent ID who sold the product to that customer, his name, the price paid, and the quantity. So each one of those, try to pause the video and think about it. Which one of those are dimensions? Which one of those are measure? Okay. Now, if you're gonna look at this in Excel, as you can see here with the highlighted value, that those all the darker color are the dimensions, and the one left in white, those are the measures that you can do mathematical operations on them. Now, the problem is now how we can consider those as a single table to be handled in Tableau. So we're going to look at that, how we can do that, and how we can you know fix things like that, because technically how Tableau likes to look at things, the way we see it here, this is okay, this is perfect, because each column represent information in the data. But typically sometimes in Excel you have a cross tabulate, like you will see information in each row. The first the first column, each row represent, like for example, customer ID here, and the price here. So this value here related to that specific customer that purchased with that price. So how we can pivot a table to be suitable in Tableau. So we're going to talk about that. Okay, so that's it. Next video I'm going to talk a little bit about the visual perception and visual design, and then some critiques about when you look at data, how you can criticize data, and how you can think about recreating that data in a better way. Okay, so that's it for this video.